Next we have standard reciprocal equations. This is a reciprocal equation of first type and even degree. So its degree can be taken as 2m because 2m is an even number. Also it has 2m plus 1 terms. Usually an equation of nth degree has n plus 1 terms. Therefore it has 2m plus 1 number of terms. And 2m plus 1 is an odd number, that is odd number of terms. So it has a middle term. That is 2m plus 1 terms means we have first m terms, then a middle term, and after that also m terms. Okay, so that total 2m plus 1 terms. Okay, see the equation. First m terms starting at a0, a1, etc., am minus 1. These are the first m terms, and this is a middle term. And after that we have, these are the first m terms, and this is a middle term. After that we have m terms. Okay. Also see the powers leading x raised to 2m, coefficient a0. Then what happens? This 2m can be considered as 2m minus 0. And here we have x raised to 2m minus 1. That is 2m minus 1 means this one. Likewise, what about this am minus 1? Is x raised to 2m minus of m minus 1. That is m plus 1. Okay. This is a middle term, am x raised to m. After that, what about the coefficients? This is a first type, therefore this coefficient and this coefficient must be equal. Term is x raised to m plus 1, m minus 1, etc. going. Last but one is a1x, because second one is a1, therefore this is a1x, and plus a0, that is first one is a0, so it is a0 equal to 0. This is the form of a standard reciprocal equation. Okay. Then how to solve it? We can solve it first by dividing this as a whole by x raised to m. That is half the power, x raised to m. Dividing throughout by x raised to m, we get a0 x raised to m plus a1 x raised to m minus 1 plus etc. plus am minus 1 x plus am. Middle term, we have am x raised to m divided by x raised to m cancels am. Then we have a m plus 1 divided by x, etc. going, plus a1 by x raised to m minus 1 plus a0 by x raised to m equal to 0. Okay. Pairing the equidistant terms from the beginning and end, that is first and last, pair, take pairs, second and last but one, etc. Pairing we get common coefficient taken outside, a0 x raised to m plus 1 by x raised to m plus a1 x raised to m minus 1 plus 1 by x raised to m plus m minus 1 plus etc. plus a m minus 1 x plus 1 by x plus am equal to 0. Equation 2. Here put x plus 1 by x equal to y. We have the result x raised to r plus 1 plus 1 by x raised to r plus 1 equals x plus 1 by x into x raised to r plus 1 by x raised to r minus of x raised to r minus 1 plus 1 by x raised to r minus 1. So result, put r equal to 1, what happens? It is x square plus 1 by x square is equal to x plus 1 by x into x plus 1 by x minus x raised to 0 plus 1 by x raised to 0, that is 1 plus 1, 2, minus 2. And this x plus 1 by x is y, that is y into y minus 2, the y square minus 2. That is, when we substitute for x plus 1 by x as y, then x square plus 1 by x square will be y square minus 2. Again, r equal to 2, we have x cube plus 1 by x cube is equal to x plus 1 by x and x square plus 1 by x square minus of x plus 1 by x. That is y into, is already x square plus 1 by x square is y square minus y into y square minus 2 minus y. That is equal to y cube minus 3y. Thus, similarly, we can find x raised to 4 plus 1 by x raised to x raised to 5 plus 1 by x raised to 5, etc. These are all found in terms of y. Okay. And substituting the equation 2. Substituting in equation 2, we get that equation 2 is changed into an equation involving y only. That is an equation y, and we can solve for y. And for a fixed value of y that we have obtained from that equation, what is y actually? Is x plus 1 by x. Then we have x plus 1 by x equal to that y, particular value of y. Then that, when simplifying, it will be a quadratic equation x and can be solved for values of x. Thus, we get the values of x, that is roots of the given equation, that is a given standard reciprocal equation 1. Okay.